Hi, I'm Pagata12 and today we play with elastic forces and at the end of this tutorial we'll recreate these crazy lines with one end sticky, and this is my second tutorial on this topic. As first one here 2 years ago, it seems I missed something, and recently I watched the second tutorial of Daniel Schiffman, and I realized what I did wrong, and it's something about kinetic energy, and yeah, we'll find a fix for that. It's nothing too complicated, so we'll recreate this file from scratch. And so let's start, but first I want to show you what we're gonna build, and we have not one but several points A which are sticky, and some points B to form pendulums, and also the possibility to chain multiple springs in one line. And here is the formula. It's very easy for the elastic. So let's start with a constant, and we go with resolution X 1280 ratio. It's 16 by 9. Okay, and yeah, we go with columns and rows for the spheres. So columns, we go with 5 for the moment, and maybe rows 3. What else? Radius, and yeah, maybe the length of the pendulum. So 0.1625, and radius is 1 divided by 128. Okay, now let's have a null and another null in between, and with collapse selected we form this folder. We name it data. We don't need this null. Go inside. We need to select resolution X and ratio, and rename this into resolution Y. And now we have math with divide, and we use a merge. Okay. What else? We can have here keyboard in, as we will use feedback, so rename this into something else than K. So reset seems nice. Okay. Now, in order to align several points in the middle of the screen, we use a ramp. Okay, and let me open this. We go with columns by 1, and this is 32 mono nearest pixels. Okay, now I want to have a constant with the same resolution, so and I go with the middle of the y-axis, which normally would be 1 divided by 2, but in this case we use ratio, so it's 1 divided by 2 divided by the ratio. Okay, with a reorder, we take input 2 for the green, and this has to be RG. Okay, now chain a null, and let's set this nearest pixels. Okay, now I would like to see this texture, so I use geometry, camera, and a render. Okay, so like this. In the geo, I don't need this torus. I use circle SOP, and we go with this radius. Okay, and turn on the blue and purple flag. This camera is orthographic, bottom left, and one here, and also constant material, okay, for the colors. So like this. And I'm ready to instance. Instead of having those this final texture, I will use a select top, and I'll grab this here, okay, and I'll have a null, and yeah, I will name this position, okay, and I also color this into crazy colors, okay, like every texture that I'm using into instancing, okay, not this, okay. And now I drag this here and take red and green, and here I'll have a null, and before that RGB key to set everything on black. So here I need 32 RGBA. Now let's split the screen and make some room here. Also again top to bottom, and I want to have the top here. So the end result, I'll have it here. Okay. And this one, I don't need background, and I'll see the network like this. Now, I have the A points. How can I have? Let me insert a null here. We'll need it later on when we start with different points. So I'll have the points here, and now I use noise to form, not this one, sorry, noise, and I connect both of the inputs, okay, like this, and not monochrome, doesn't matter what amplitude we use, as we subtract those two. So subtract like this, and now we use normalize. So let's have a null. Oh, sorry about that. So a null, and in between here let's have a composite. Okay, collapse selected. I'll have this folder which is normalize. Okay, and let's go inside. We have composite. This should be transform input 1 and divide, and now we use math with length, mask the alpha, and this is 32 mono. And if we connect like this, select all nearest pixels. Okay. And now we have here one length vectors. So we use math, and we multiply with this length. And now if we add this texture above the input points, we have the B points, the second set of points. But I would like to make this a little bit different, as I want to have many rows, okay? So yeah, like we have 3 here. So let's have a ramp. Okay, we go with columns and rows for the resolution. And this has to be nearest pixels, 32 mono, and I would love to have it vertical. And also, a bit inverse, as I would like black to be at the top, as it represents the distance to the sticky point. The sticky point is at the top. We start at the top. So we can do this with limit, and yeah, with limit 1 to 0. Okay, and now we multiply this texture. So actually we do it like this, and we set this texture to be 32 RG. Okay, and now we use add like this, and yeah, let's see the result. Let me make everything. I will lift those up here. Okay, everything here has to be nearest pixels. Okay, now if we play with the length, okay, we can change this. So this is good. Now normally when a spring is in a rest position, it doesn't do anything. Okay, so what if we change it a little bit? Okay, just a little bit of tension. So we can do this by inserting a little noise here. So if we have a little noise here like this, you see we have some differences. Okay, so normally if we apply the elastic forces, we will see some movement. Okay, now let's solve those forces. Okay, now here is the initial point, the second point, and yeah, the interpolation method, because we can have as many points as we want. So let's go with 16. Okay, so this is the fastest way of interpolation between 2 points, A and B. Okay, now to find out the force, we select this null. Okay, and you want to transform with pixels on y-axis with -1, and then we go with subtract, and yeah, let's use a math here with length, mask the alpha, and this is monochrome. Okay, now this is where we have the distance between 2 points. Don't mind this top row, which yeah, if we take this with hold, how it should be, yeah, it's 0 there. So, but we do have some values of gray here, so very small distance. Okay, now the x in the formula, it's force is equal -k multiplied with x. X is the deformation. So we compute the distance between 2 points, and then we subtract the rest length to see if it's stretched or pull. Okay, or press, and the force will go in the other side. Okay, now for that we use a math here, and let's see the rest length. The rest length is this length here, so it's this 0.1 length. Okay, and it's divided by how many points? -1. So you see the distance in between the points is length divided by how many they are, -1. So let's do this. Length. Okay, I copy this. I use minus, and I divide here with yeah, I should use a parenthesis before. this is rows, okay, -1, and close the parentheses, okay. And here we multiply with -k, so yeah, it's time to give k a value, okay, 0.1 maybe, let's see, and we drag the k here with minus, okay, and now we multiply this, because right now we have the value representing how strong the force is. The direction, we take the direction from this texture, and we copy and paste the folder, the normalized folder. So we use it again, okay, and we go in this multiply. Now we have a texture, okay. This here would be the force, and we need to add it to where we have the points. So we use a feedback. Okay, let's make this black and drag the reset for reset and pulse, and this should go with add, and we get this texture with a feedback. Okay, so let's use again a feedback. We need a constant to initialize the feedback. So constant. This is 0, 32 RG, and columns by rows. Okay. So yeah. And I'll take the null 4 here, and we add those two, and we go like this. So yeah, let me set everything to nearest pixels, and you see now they act like springs, and we only did the half of the work, because nothing drags them down, and I'm not meaning the not down, but the forced. We just find out that the forced to the point above, and the force to the point beneath. It's like this. So let's copy those two. Okay. And here we transform with 1, and we add those two like this. And now you see the extreme points are moving. We only have 3 points, so the middle ones stay still. If we take 4, we'll have something different, okay? But we need to set the sticky points. The sticky points, it's something that we have to keep the initial position for those sticky points, okay? So that means if we multiply here, let's have a constant 1, okay, and this is mono, okay, and now we transform, because we want to have an empty row at the top. So with -1 like this, we have that, and that black row, it's actually 0, so that means we can multiply like this. And now the points are sticky, okay? And let's see what else we can have. We can have gravity. How we add gravity? So with a constant, the RG constant, okay, and this is -1. Let's start with that, and now we have math, and yeah, we take just a little bit of that, and we divide with how many pixels we have on X, okay. Now I would like to add this here, and we go like this, okay, and now we add gravity, okay. Now you see the moving is slow, and it never pass the vertical line in this case, and this is because we need to solve that kinetic energy, and this means from each previous frame we keep a little bit of velocity of that force, and we go on with that further away. So that means we might need to change here a little bit. So let's have the gravity just a little bit later, because right now I would like to have another feedback like this, and I would like to add, and I use a composite with add like this, and I do this. So I'm dragging the add into this feedback. Now everything goes crazy, okay. Now this is because maybe we take too much from the previous frame, so let's use a math here and go with 0.5. And it's good, but we still have some jiggling motion, which is not necessarily good, and we'll find a fix for that. Okay, you see, even when we add the gravity, and this is because this k is a little bit too big. So if we set this to 0, 1, everything it's good, but the lines get longer. Okay, let's have some lines actually to see them better. So I will go with transform, and I use pixels, and here I go with 1, not 2, and I do subtract in between those two, and now I found the length with a mask the alpha, and here we have the length for the lines, okay. And yeah, instead of 0 here, let's go with holders. I would like to have the last line being 0, okay. Okay, a null here. I will make this some crazy color, and now let's copy those two, and I need a render pass. Okay, and this one takes GO2, the render takes GO1. Okay, and yeah, let's go inside the GO2. We need a line sop here. Okay, and the line should be on z-axis, so 1 here and 0 here. Okay. Now we good, and we see we have a bunch of lines here, okay, but they are too long. So let's use this null in the scale, and we scale with red value for the z. Remember, the line, it's on the z. The line gets smaller, and now we use also this texture for rotate 2, and we drag it here, and we go R, G, and B, and yeah, choose second or third, and plus Z, and now we good. And let's use an over here. Okay, now we have the lines, and let's have them a different color maybe, and also a little bit thicker, like this. Okay, and yeah, if we lower the value for the gravity, okay, they get shorter. Okay, so it's less force, but then it gets slow. Okay, and let's turn back to -1. Okay, now the moment you add more rows, because with 2 rows it's simple. Okay, we can even increase this to 0.9 maybe. Oh, that's something. Let's see. Okay, now you might have some lines flickering, and that it's because they don't know sometimes where it's up vector. So yeah, what I like to do is have a constant like this, and I have an up vector. This is 32 RGB. Okay, and this is something I use like here. You see, you don't see the lines, so I use it here in rotate up, so R, G and B, and we should be good. No, just a second. Oh, for the constant it's set resolution only. Okay, now we good. So yeah, they balance, they pass the vertical line. It really depends on this this little value, which if it's too big, you will lose them. Okay, also if you increase the number of the rows, so let's go with 8, right? So yeah, they will get very long, and then they will get a bunch of errors. And how we solve this? Okay, now in order to see them better, we can lift them up and make the sticky line to the top of the screen, and we do this by using 1 instead of half here. So okay, now yeah, we can lower the gravity, and it's something else, but still the errors are there. How we solve this? Okay, and for this, what I'm thinking, it's blur, and let's do this. So here in between feedback and add to, we insert blur. Okay, and everything gets lost, because we make a folder and we name this tension. Okay, and yeah, let's go inside, and inside we also need this texture for having things sticky. Okay, so here I'll select this texture. Okay, and yeah, I want the blur here, so I multiply with the blur, and here I use level with invert. Okay, and this I multiply, and so I have the top row, and now I add them. Okay, and let's reset now. And wow, interesting. What's happened is we use blur on vertical and horizontal, and there's no need on horizontal. So let's go here, use vertical. Okay, and now everything it's nice and smooth, and we only need 2 for the blur, not more. And yeah, let's see now if we increase this. Okay, so now it's going much better. So yeah, maybe 0.2. Okay, and yeah, what if we increase this? Yeah. And what else now? If we take a lot of columns, like 2, 5, 6 columns, okay, and obviously the radius should be way smaller, so I go with 512. Okay, we have this, and they all go with the same speed, and they are equal in length. And what else we can do is use a noise here. So I'll have a noise, and this one, yeah, it's just a little noise. We can play ABS time dot frame divided by yeah, 1024. Okay, what else? We can select the feedback and map the noise where we have the points, and now they will form some clusters. Okay, so let's see, and maybe if we increase, let's see. Yeah, so the moment we increase the K, we have them. Okay, now let's solve the colors. Okay, so for the colors I would have the initial position, so I'll take this null. Okay, and I need a noise mapped on this, so noise and map here. Okay, now we take columns. Let me open this window again, and yeah, let's take columns and rows. No, and this should be 32 RGB. Okay, let's have this color, and now for the lines, I'll grab this texture for the color RGB. Okay, and instead of this blue, we turn back the white, and yeah. Okay, now if you want to have this motion longer, like you know, you can increase the gravity, and they will grow, and you can also use here a lot more rows, like 64. Okay, so now you have something like hair, or yeah. You can lower this to 0.1 and do all sorts of fine tuning. Okay. What else I want to show you here is If you copy this folder tension, okay, let's connect this. Nothing happened. Maybe they get smoother, okay, because we blur them 2 times. But let's go inside, and instead of blur, let's use pixelate. Okay, what pixelate does, yeah, it does some very nice clusters, like here. You see? So let's get rid of this blur. Okay. Now we don't need the vertical, and by having column and divided by a number, we have 16 yeah, clusters. Okay, and we can play with dry and wet mix, and we get those nice tentacles. Okay, so yeah. What else? What if we start with a different position? Okay, what if we instead of having a line, we have a circle? So for this, let's use a null, and here in between we chain a null, collapse selected, and we name this circle. Okay. Now we go inside, and first we want to use a mat and multiply this ramp with 2 pi. So mat dot pi multiply with 2, and here we use function 2 times, 1 for cosine, and this would be red and also radians, and this is green, and we go with sine, and now we reorder this. Okay, input 2 here, this should be 32 Rg, and yeah, what if we use this for our points? Now if we have a look here and view as points, we have a circle with a radius of 1. So what if instead we go like mat, okay, we multiply with 0.1. okay, we want a circle to have a 0.1 radius, and then I want to move it in the middle of the screen, which is 0.5 for the x, not for the y. Let's see what we have now. So we have a circle there. Okay, now in order to put it in a correct manner on a y, what if we use another mat? There are many ways to do this, okay, and this mat will correct the green, and yeah, we subtract the 0.5. Actually, it's much better. We subtract the 0.5, but only for the green, and now it's here, and we need to add, or for the y, just half of the ratio. It's 1 divided by the ratio, actually. So yeah, let's get the ratio, and not multiply, but add here. No. Okay, not length, it's a ratio. Oh, something wrong. So let me check. Okay. Oh, I did something wrong. Okay. Let's try again. So I subtract 0.5, and then I add. Here it's 1 and half divided by the ratio, and this should go only for the green. Okay, now it's in the middle. Okay. And what else we can do now? Let me take off the circles. Okay, and yeah, here you see some circles, but you can press deep pill, and yeah, we have only this. In order to arrange the lines like in iris of an eye, you need to work a little bit different, because right now for the second set of points in between in which we interpolate, okay, we go with noise. So but yeah, it's good for now. What else you can do? Let's see. We can rotate this, okay, with point transform, and let's set the middle. The middle is 0.5 here, and yeah, let's use this ratio in order to set the middle for the y. And now we rotate with ABS time dot frame divided by 1024. Okay, and yeah, it's fast, and I can divide again with 1024, and it's better. And if I want, I divide with 4. So now yeah, we have something else. And yeah, you can fine-tune this how you want. If you take off the gravity, and yeah, and let's see what time we have. So how about those sticky ends, right? And yeah, what if instead of the line or a circle, we just go with the noise? So let's go with the noise. We take columns and 1 for the resolution, RG nearest pixels, and yeah. What if we use those? Let's see. Now, obviously, we don't need the point transform with rotation now, and maybe we don't need this. Okay. Now, I would like to have less rows, 8. Okay, and this noise, maybe it's 1/3. Okay. Also, I want to see the points, but maybe I'll take the color as the lines. So R, G, and B. Okay. Now, to make the sticky ends, right now one end is sticky, okay? We can do this using transform, and this time we go 1 pixel instead of -1, and we use a switch here. Like this. And for this switch, we can use a noise chop, and we take time slice, and here with a mat we go around and we drag this value into the switch. So let's see what happened. Yeah. So the other end get sticky, and yeah, the elasticity will drag everything there, and you get this type of motion. And what else you might want to do here is to limit this. So let's insert a limit, collapse selected, okay, and yeah, limit. Go inside and use a limit with zigzag in between 0, 1. This is only for the X, and so we mask the green, and now we do the same for the Y, okay, and instead of 1 we go with 1 divided by the ratio. And by doing this, your points will not leave the screen. And yeah, playing with the value of the gravity or the noise, you can change the speed for this. And also something I've noticed, if you take a smaller length, then they will start to, or maybe longer, I don't know, I'm not sure, yeah, a longer one, they will start to form something like a zigzag. Okay, so yeah, you can experiment with this. And you can fine-tune this as you want, but yeah, I'm thinking if I did cover everything I planned for this tutorial, and yeah, I believe this is it. And thank you so much for watching. I really like. I really hope you to like this. And actually, a lot of things I've done with this algorithm. And remember those errors. And yeah, there's another approach, much better or much precise, and it's best suited for simulations. And that is Verlet integration. I'll have that on my Patreon, but I really wanted to find some tricks for this very simple method. And yeah, this tension with blur and pixelate, it works great. So yeah, thank you so much. And I want to thanks to all my Patreon. It's been 3 years now, and yeah, I can't thank you enough for supporting me going with this research. Thank you so much, and I see you in the next one. Bye.